Hello everyone. In this video, we're going to do another look at confidence intervals and how to use both our flowchart to help figure out which equations to use and actually how to utilize them. Let's look at another problem from a previous final. So let's look at this one. GE, the manufacturer of clothing washers, claims the mean lifespan of their washers is 5 years. A random sample of 30 washers is taken. Their mean lifespan is found to be 4.8 years, with a sample standard deviation of 0.6 years. Determine a 99% confidence interval for the true mean lifespan of the product. Okay, so the first thing that I am going to do here is I am going to determine what is our data, what question is being asked. So let's look at our question. And the question is like, how long did the washer last? And so our variable maybe is like washer life. And it's going to be measured in years. And so our data type is going to be numerical. We are responding in some sort of number, being the number of years. It could last for 5 years, it could last for 10 years, it could last for anywhere in between. So this is like a piece of numerical continuous. And years is also, let's also add this on. This is a good piece to add on. So it's numerical. We can say that it's continuous. And it is a piece of ratio data. Which means that it has a true 0 point, that if it had said that it lasted for 0 years, I guess it's broken from the start, and it can't go any less than having a life of 0 years. Okay, so we know that we're dealing with numerical. So if we look at this is our page 3 again, and if we look at our options here, we have the numerical data, and we have our categorical data. So we're going to go up and look at our numerical, and if we look at our numerical a little bit closely, we see that, hey, there are two options here. Do I know a population standard deviation or do I know a sample standard deviation? And that will allow me to figure out the key variables that I need for this scenario. So let's look. So it says a random sample of 30 washers is taken and their mean lifespan is found to be 4.8 years with a sample standard deviation of 0.6. Notice how it says sample standard deviation. So I don't know the population standard deviation, not a problem. I know the sample standard deviation. So I'm going to work on these key variables right here in order to build off of the sample standard deviation is known. So those are the set of variables that I'm going to be working with. Okay. So at this point, I'm going to start working on a few things that I do know. So the first thing that it gave me a sample size, and it gave me a sample size of 30. Now remember, confidence intervals are built off of the idea of the central limit theorem. We need the central limit theorem to check out. And it doesn't say anything about the original distribution of these washers. I don't know. But because we have a sample size that is at least 30, we know that the sampling distribution will be approximately normal. So we can move on. We know that we are in a good spot. So we've got n is equal to 30. Okay, the next time it says their mean lifespan is found to be 4.8. So I'm going to call this as x bar is equal to 4.8 years. And then we have a sample standard deviation s, which is equal to 0.6. Okay, so I'm just starting with those because that's just what's given here. And then I'm going to go over to my key variables and take a look at some of these. I'm actually going to take what I know and I'm going to just drag it over to the side. I'm going to order it into the order that I want in just a second. The first thing that it asks for is a confidence level in my key variables. So the confidence level that it asks for is a 99% confidence interval. So I'm just going to be 0.99. I then know that my alpha level is going to be equal to 1 minus our confidence level. Great. Next thing that it wants is a sample size. Okay, I got the sample size already. I'm just going to drag it back over there and just put it in order. And then under here, it says that, hey, I need a degrees of freedom. I'm just going to go degrees of freedom equals, and all it equals is the sample size minus 1 to get our degrees of freedom. Excellent. Next thing that it wants is an x bar and the standard sample standard deviation. I have both of those things. So I'm just going to drag them over. And then we want the standard error. So let me kind of minimize that. Let's go standard error is equal to, if we look at S, the sample standard deviation divided by the square root of n. Easy. Sample standard deviation divided by the square root of n. and we'll hit enter, and we got my standard error. Okay, next thing, we need to know, are we doing a two-tailed interval or if we're doing a one-tailed interval? So up here, look at our problem. The way that we know if we're doing a one-tailed or a two-tailed interval is if it gives us some directionality, like we want a 99% confidence interval that we're going to be at least some value, or 99% confidence interval that we're going to be no more than some value. Right now, it doesn't say anything. It just says determine a 99% confidence interval. If it doesn't give directionality, it's going to be a two-tailed. So we're going to do a t, 2t, for a two-tailed t value, and we have a very simple equation that we do. We're just going to do equals t dot inverse dot 2t, parentheses. It's going to ask for the probability over here. That's the probability that we're going to put in is just our alpha value. So click on alpha, and then we're going to do comma, and we need the degrees of freedom. Be sure that you click on the degrees of freedom and not the sample size. We're going to close our parentheses and hit enter, and that is our t critical value. That's our two-tailed t critical. And then let's just get our margin of error. MOE is equal to, and let's do our two-tailed, we'll do equals to the two-tailed t score, and then times our standard error, and we have our margin of error. Before I do anything, I want to see if I can't get a rough guess of where I think that this answer is going to be. So let's go ahead and draw this thing out. Let's start off with just drawing out our distribution. We've got a nice little normal distribution. And remember, typically, the sampling distribution, if we were to do this sample of 30 over and over again, it would center this distribution on the true mean, which I am interested in. I want to know where the true mean is. But the problem is I don't know where that true mean is. So instead, I'm going to center this thing on my next best guess, on my x bar. This is my single best guess of what's happening, which is 4.8. Now, I don't know anything about the original distribution. I don't know if the original distribution is normal or not, but it doesn't matter because I am going to be looking and using the distribution of the sampling distribution. So this is going to be my standard error. Be very careful here. It's very common that people decide to use the sample standard deviation instead of the sampling standard deviation. That's the correct one, not the sample standard deviation over here. That is not correct. So let's go ahead and erase those out. Just to be easy for me to write out, I'm going to round this to 0.11 for my standard error. And then I'm going to add these up. So this is going to be not 4. Sheesh. It is going to be right. Will be 4.91, and then we'll go up again. We'll be at 5.02. We'll go up again, and we'll be at 5.13. All right, so that's kind of just moving up for 3 standard errors. So we'll go down the other way. We're now going to be at 3.7, go down another 1.1. We're now at 2.6, and another 1.1 will be over here, which is going to be at 2.6. Oh my gosh. Let me go back. I'm crazy. This isn't how you do this. Do your calculations carefully. So this is going to be 4.69, because if we add 0.11 to that, that gets us to 0.8. Oh my gosh. Okay, here we go. We're now going to subtract another 0.11, which is going to be 4.58. And then another one down, it's going to be 4.47. Sheesh. Okay. Much better when we look at it like that, when we step up and down by 1 standard error, when our standard error is 0.11. Okay, so if this is my x bar, let me go back to my home, or let's go back to draw. Let's get a different color. We'll do purple. So I know that my x bar is going to be centering up my confidence interval for my two-tailed interval. And I know that like plus or minus 1 standard deviation is 68, plus or minus 2 standard deviations is like 95, and plus or minus 3 standard deviations is going to be 99.7, which is really close to the confidence interval that we want. So I'm just going to maybe suck it in just a tiny bit from those ends. So I think that our cutoff points are going to be like 4.48, just a little bit above, to 5.12. That's where I think that these values are going to be. Let's go and look, without doing any calculations, if we were close enough to answer this thing correctly. So if we look at our answers, my answers that I guessed, remember I'm just guessing, is 4.48 to 5.12. And this first answer is 4.49, 4.5 to 5.1. That's really close. None of these other ones are in that ballpark, except maybe this last one, but I don't think that last one is correct. So if I were moving fast and I needed to, I'd actually be really confident in this A value. But let's go ahead and calculate this thing out so that we can actually see what's going on. Let's go back over here, bring that over. How do we calculate out a two-tailed confidence interval? Oh, the lower and the upper is just x bar minus the margin of error and then plus the margin of error. So we're just going to go lower and we'll call upper. And the lower is just going to be equal to x bar minus margin of error. And now we'll do equals x bar plus the margin of error. So I was able to get really close to those answers just using my graphic. Those graphics are a great tool in order to help you just contextualize what those, or internalize what those answers are going to be. Okay, so we can say what critical value was used in this construction. So like, okay, yeah. Do we use a T or a Z critical? Well, over here it told us immediately that we needed to use a two-tailed T. So it wants the T critical value, and which one did we wind up using? Let's go see. Give me just a second. Okay, let me shift this off to the side, and we can see. So we had a T score of like 2.75, and or if we round it up, 2.76, and there it is. We answered those questions. So that was 2 questions on the final that we were able to answer really quickly using this flow chart of how to figure out these key points on our confidence intervals with respect to means. So let me give you real quick. So what does that 2.76 mean? That 2.76 means that we started from here and we went 1 standard error, 2 standard errors, and then like little past 3/4, right? The T-score is just telling us how many standard errors away from the mean did we go in order to build this confidence interval. That's it. Okay, good luck. Hope that helps you again at seeing another problem on how to answer confidence interval questions using our Excel tools and our flowcharts. Best of luck.